Welcome to a lesson with Dr. Pal. Let's talk about some basic set operations. Union, intersection, set subtraction, disjoint union, subset of. Okay, let's start with subset of. What does that mean? Well, if I have two sets, A and B, one is a subset of the other. This is the notation for it, meaning like if this is like 1, 2, and this is 1, 2, 3, see, this is a subset of this set right here. So we can use this symbol freely like that. Okay. Now, what about these two different directions? Well, that's just simply because we could have written the exact same thing like that. If we wanted to write B first, it just means B contains A as a subset, which is the same thing as A is a subset of B. Just like we can order our words differently, but you get the same idea across. All right. So what about this guy, this union? Let's look at an example to describe that. So if we have a set 1, 2, 3, and another set 3, 4, 5, the union of these two sets is the smallest set such that both of these guys are subsets of it. So let's suppose this is A and this is B, and the union we write down as A union B is going to be the smallest subset that contains both this guy and that guy. So what does that mean? It's going to have all the same elements that you see here and nothing else. And if something is repeated, we're just going to take one instance of it. So here we have 1, 2, 3, even though it repeats, we just write it once, 4, 5. So we just kind of put the sets together, and any overlap or repeats, we just keep it what it is. And that is what the union of those guys are. Now, if we're thinking about, if we're visually thinking about regions in a plane, perhaps we have a set A, which is like a circular region, and maybe a set B is another region over here. So we have a region A and a region B. Notice they have an overlap. Well, the union would simply just be to shade this together, shade this. And what I just shaded was A union B. Even if A is over here and B is over here, A union B would just simply be the conglomerate. Even though they're not attached, there's no intersection, but still A union B is just everything in here and everything over here. Okay, so that is the union symbol. Now, what about the intersection symbol right here? Well, let's just look back at this example where we have A and B. The intersection is simply just the overlap. Okay, so now in this case where we had like A and B over here, then we would have A intersect B would be empty, and we can use notation for empty set right there. Okay, so we can look at an example with with lists. All right, and back to what we had here. What if we had 1, 2, 3 again, and 3, 4, 5? Then we could notice the overlap. What's the same in both? 3. So we can say A intersect B is equal to simply 3. So that's the intersection of A and B. Okay. Now let's take a look at this next set operation, set subtraction. What does that mean? Well, let's just look at this case where we have A and B. A set minus B, or A minus B, is simply everything in A. So we start with A and we just take anything in A out of it that happens to be in B. That's all that means. So B does not have to be a subset. We're just, with this notation, this is just notation, this just means simply that just take out anything that is in B from A. So this should just be 1, 2, because we're taking out 3 since it also occurs in B. Okay, now we're on to disjoint union. There's 2 different notations which are often used, and they have various purposes. Okay, so this notation right here is often used to express kind of a dual quality between something called Cartesian products in itself. But nonetheless, it's also used in other contexts too. This one just simply means the same thing. But what is disjoint union? Disjoint union means that if you have 2 sets, you want to unite them, but pretend like they don't have any intersection. It can also be used when you have sets that just don't have any intersection and you're expressing a union between them, but you want to emphasize the fact that they are disjoint, meaning that their intersection is trivial. The A intersect B is the empty set. So if A intersect B is the empty set, then we can write A union B with this way, or using this notation, equivalently, we could write that. I will stick with this notation right here. Okay, so for instance, let's suppose that we have some sets. A is equal to 1, 2. B is equal to 3, 4. And C is equal to 5, 6. We can express the union, A union B union C, which is just simply all these put together. 1, 2, 3, 4, 5, 6. Notationally, we can write A disjoint union B disjoint union C, and they mean the exact same thing. But it just emphasizes the point that these had no overlap. So only use this notation when you don't have an overlap. Now, it is true, even if they have an overlap, you can still use this notation, and it does have a meaning. It just means that you've run to the copier and took copies of things, but the copies can't correlate. So you end up getting repeats of things in the list, but one repeat, you have to memorize where it came from. Came from A or came from B, maybe put a subscript on them. But we won't use it for that in that way. We'll just use it to emphasize the fact that maybe 2 things are disjoint. And in this way, what we can say is that A, B, and C partition this set. So what's a partition? It's simply just sets that have a disjoint union making up a set. So you can say A, B, and C partition what their disjoint union. Thanks for watching.